Good day to Dr. Juliawati. My name is Sharvindiran Ramaya, metric number MH190552 from Group 4. I am going to start my group's presentation of Lab 9, rolling disc on an inclined plane, long report. So starting with the introduction, first we will see free fall. Galileo Galilei proposed the amazing finding that all free falling objects fall with the same acceleration over 400 years ago. Regardless matter the mass of the ball used in the experiment, the relationship remained the same. The experiment was successful. Rolling motion. Every day we observe rolling motion, which is a frequent combination of rotational and translational motion. Consider how wheels on a car driving down a highway, or wheels on a plane landing on a runway, or wheels on a robotic explorer on another planet move. Then moment of inertia. Rotational inertia, the rotation analog of mass for linear motion, is known as the moment of inertia. Below, I have provided a diagram of common moments of inertia, which shows different shape of objects have different calculation for the moment of inertia. Theory. Acceleration of free fall is g equals n 9.81 meter per second square. Initially in the lab sheet, the moment of inertia was given j equals 1 over 2 mr square because in the lab sheet it was a symmetrical disc shape. But in our experiment, as we have used a volleyball and a golf ball, which are both solid sphere, the moment of inertia is calculated j equals 2 over 5 mr square. The acceleration remains the same, a equals mg times sine alpha times r square over j. The objective of our experiment is to able to know the mass moment of inertia by rolling experiment, the law of falling bodies on an inclined plane. Moving on to the experiment setup. Number one, we need a flat wooden plank, which is used as an inclined plane. Then we readied some folded newspapers to adjust the height of angle inclination. Then a stopwatch using our phone. Then Angle Meter Pro Plus app, which we downloaded in the Google Play Store using our phone as well. Then a volleyball, a golf ball, and two stool table as a base for our inclined plane. Then for some technical data, the volleyball is measured outer diameter 230 mm, roll radius of 53.25 mm, a mass of 270 gram. The golf ball has an outer diameter of 42.67 mm, roll radius of 10.67 mm, a mass of 45.93 gram. Meanwhile, our inclined plane, which is the wooden plane, which goes up a maximum length of 1000 mm, which is 1 meter, and a maximum angle of inclination 7 degrees. Okay, that is all for my part. Now my friend will continue with the experiment procedure. Thank you.
Hello, good evening. My name is SOBAN GOPALKRISHNAN and my metric number is MH19054. Today I'm going to present about the experiment procedure. Okay, we conduct the test 1 inclined plane. First, set up the wooden plank to be stable on 2 stool tables. Second, set the desired inclination of the flat wooden plank by placing folded newspaper below one side of the wooden plank and measuring the angle using Angle Meter Pro Plus. This app, you can download it in Play Store or Apple Store. The figure 3.0 is showing us how to use the Angle Meter Pro Plus app in handphone to determine the angle. Next, you will see the third step. Using a measuring tape, select the desired distance between 0 to 1000 mm and mark the end of track by placing a rectangular plane. So the pictures show how to place the rectangular plane and marking the end of the track by placing a rectangular plane. Okay, the fourth is place the desired lowering object. We use volleyball and golf ball for our material. So place the desired rolling object at the 0 position on the track. Make sure the midpoint of the rotational axis is located at the marking and the rolling object is positioned in the center. Okay, next we will see the fifth step. Let the desired rolling object go and start the stopwatch. At the end of the desired distance, stop the watch. Make sure the watch is only stopped when the midpoint has reached the measurement marks. So picture 3.2 show that the starting point when the material is rolling on, and the figure 3.3 is the stopping when the time to stop when the measurement mark has reached. So the sixth, repeat the measurement procedure several times in order to minimize the measurement errors. Then calculate a mean value for each series of experiment and put the result in table 1, table 2, and table 3. Okay, we're gonna see a video how the experiment is conducted. So let's watch together and thank you.
Hello, my name is SYAFIQAH. I'm going to present the result for this experiment. Table 1 show the roll time for a distance of 1000 millimeters for volleyball and golf ball. The reading for each angle inclination is taken 3 times and the average is calculated, which is the T-mean. From the result in table, we can see that as the angle increased, the time recorded decreased. This happened to both volleyball and golf ball. Next is table 2. Table 2 shows the acceleration, calculated time, measured time, and the deviation time for volleyball. The acceleration and calculated time is calculated using the formula explained before. The deviation is calculated using the formula, which is measured time minus calculated time divided by calculated time times by 100%. The highest deviation is at first inclination with 43.87% and the least deviation is at third inclination with 0.67%. From the table, we could also see that the acceleration increased as the angle increased. Table 3 shows the acceleration, calculated time, measured time, and the deviation of time for golf ball. The acceleration, calculated time, deviation is calculated using the same formula as that we use in Table 2. The highest deviation is at first inclination with 28.97%, and the least deviation is at fifth inclination with 6.07%. From the table, we could also see that the acceleration increased as the angle increased. This is the same as Table 2, which is for volleyball.
Okay, proceeding to discussion. So first, how to adjust the angle of inclination. The angle of inclination is adjusted by increasing the height on the plane on one side. It is done until a tilt is occur, and that increases the inclination angle. Second, what is the purpose of angulometer? Angulometer is an instrument for external angles. The instrument is placed on the flat surface and the angle can be read off it. Number 3, can you give an alternative method to measure the angle of inclination? Okay, so first, the usage of hand level is simple as it is placed on the surface and the liquid will indicate whether the surface is tilted. Proceed to number 4, how to make this precise alignment for this experiment. So we choose a flat surface so that we can use an app on the phone to check whether the surface is flat or not. So number 5, why is the angle higher than 7 degree cannot be used for this experiment? So the angle lower than 7 degree keep the ball in motion of rolling and slipping won't be occur. It is also within the critical angle. So number 6, give the definition of free fall theory which discovered by Galileo. So a free fall body undergoes uniformly accelerated motion in close proximity to the Earth when the air resistance is negligible in relation to the weight and body. So number 7, give the factor that cause free falling body, mass of the object and acceleration of the gravity. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL binti AZMI with Metri ID MA19321. So I will present my part of discussion from question 5.8 to 5.13 and the conclusion. So from question 8, it asks us what the relationship between angle of inclination and rolling object. For example, the rolling object that we are used during this experiment are volleyball and golf ball. So what is this relationship? So what we can say is that the angle of inclination will actually affect towards this rolling ball in terms of velocity. So the higher the angle of inclination, the faster the rolling object will move. So the higher its velocity. So next question asks to explain the term of inertia. So inertia actually is the resistance to change in motion. When an object moves, it will never stop moving unless there is an external force acted on this object. For example, when we push the volleyball onto a table, it will eventually, after some time, it will eventually stop moving. Why? This is because there is a friction happen between the surface of this ball and the surface of the table. So what happens if there is no force at all acted on this volleyball? Then it will never stop moving. Next question asks to explain why the repeatability in measuring are important. This is important because we wanted to gain a certain result. We want to gain a true result, a result that we can say that are the true results for this measuring. Because the first measurement that we do might have an error on it. For example, the technique that we are used are wrong or the uncalibrated tools are used. So there is uncertainty on it. So in order to remove this uncertainty, we must do repetition in measuring. So we can obtain many value, and then from this list of values of parameters, we can eventually see that this value will have the same value around the same value from other 2 or 3 values. And then from this list of value, we can make an average, and then we can gain the true results for this measurement. Okay, next question asks to draw the FBD diagram of a rolling object. So I draw this FBD diagram with 2 situations, for a flat plane and an inclined plane. So as you can see, this is the force, the mass of the object pushing downwards, pulling the object downwards due to gravity, and then there is a normal force acted the opposite of this force, and also there is this force that make the rolling object move. So you can see the differences between an inclined plane and the flat plane. Inclined plane will difference in calculation that we have an angle due to this incline. So next question asks why deviation occurs between calculated and measured value. So deviation is actually the differences of value between calculated and measured value. So why this occur? It might the normal case is that you can say this occur due to error in measurement. there might be error in terms of uncalibrated tools or the technique that are used. So this lead to the error in measurement value. And also, this is not measured value, but actually the calculated value. So calculated value is actually correct because it does not include any factor such as internal resistance or deformation, which measuring value have included this factor. So this factor eventually lead to the deviation occur between this calculated and measured value. Okay, next question. It asks to suggest the improvement for this experiment. So during the experiment, there is an error actually happened during this experiment. There is in terms of measurement. So we suggest to improve in terms of measuring during the experiment, the validity of the experiment itself. So what we suggest for improvement is that by controlling additional variables, that is by making sure that the experiment are done exactly the same as what the procedure told us to do, and also by improving measurement methodology, that is by the technique that are used to take the measurement, and also the type of tools that are used. Okay, as a conclusion, so during the experiment, the data that we have obtained, we can say that we can find the angular acceleration and also the moment of inertia by using the formula of mass moment of inertia and basic kinematic equation. So this is the calculated value. And what we see is that there is a major error that might be happen due to incorrect selection of starting point of roll. For example, where these both objects start, it must have the same starting point, because if it does not have the same starting point, it will actually affect in terms of its frictional effects from this between two surfaces, the frictional force. So this will lead to irregularity and uncertainty of the result that obtained at the end of this experiment. And from the experiment, we also know that we can make conclusion that the angular acceleration are constant and the angular velocity will increase as the rolling disc move. Hence, the relationship between mass moment of inertia and the law of falling bodies on inclined plane successfully achieved and determined. We can say that the objective of this report, we have successfully achieved it. So that is all from me. Thank you very much.